At this point, you want to refer to what kind of light actually exists inside your fiber optic cable. What kind of light can propagate down a fiber optic cable in what kind of message? But it's very hard to see that light sometimes. But you have access to that in your lab when you're trying to teach this to the students. It's hard to see it normally in your eye, but if you get a mobile phone or an iPad or something along them lines, turn on the camera function, and turning on the camera function, you're able to see that as the sensor on the phone can pick up the infrared band of light. However, we've got something that's able to pick that up, but you can't. At this point, after the light message in infrared has been sent down, you need to unscramble your message. You need to unscramble your message. And at this point, that's very inconvenient. But what we can do is we can replicate that in the lab. Here, we've got some different colored sweets. But with these different colored sweets, they're very easy to separate now because this has all of the wavelengths of light. And you can ask the students, why did I see the color green? Well, what we're going to do is we're going to hijack that idea and do the following. If you've access to colored filter paper and a light source, what you're able to do is add your light source to a light and only allow that band of wavelength to come through and shine it in darkness across your colored sweets, and the task is get them to separate them. Now, hopefully it's a difficult challenge, but if you don't have access to that, I suggest use a colored balloon and use the thick part of the balloon to replicate the same idea. A light, a balloon, some colored sweets, and then you can then refer to the idea of unscrambling your light message. And this is what happens in a node at the end of the broadband plan. When you're trying to unscramble your message, it's very hard and difficult. And that's what your eye is trying to do, and that's what the node is trying to do.